Asynchronous triggers can be thought of as the combination of database replication and triggers, meaning that we can replicate data to remote machines, but without the stipulation that the remote copies have to be identical to the source. This means that we're allowed to transform the data so that the target can be a different file type and even a different number of columns and keys. Our example will explore this feature using the Chili Company database as installed on a Mac, meaning that it's the standard set of mkeyed files. Our asynchronous triggers will keep a remote copy of the database up to date in near real time with any changes made to the source files. The key, though, is that in addition to our data warehouse version existing on a remote machine, all of the data files will be ESQL files, and they'll have extra columns to help us keep track of modifications. The first step involves creating the remote or the data warehouse version of the Chili Company on the remote Windows machine. To avoid reinventing the wheel, we'll use the data warehouse creation utility that's installed with the BBJ demos. This program creates an ESQL version of a database, and we can add a few more lines of code to add new columns to every table, including a column that determines if the record is active, one that keeps track of when the record was modified, and another that records which user modified the record. Next, we set up the asynchronous trigger job in Enterprise Manager with our remote Windows machine configured as the target. We'll also specify the trigger programs on the remote machine that handle all of the data modifications. These programs will automatically be launched whenever we write to our source files or remove records. They'll be responsible for getting the modified record and making the appropriate changes for the target. Lastly, we'll include the list of data files to keep in sync, and we're given the opportunity to exclude files if desired. Trigger programs cannot interact with the user, so we'll add a couple of println statements to each one so that we can tail the BBJ logs and get an idea of when the triggers run. This excerpt shows that we get the trigger data object, then from that we get the key and the user that's removing the record. We then log this information out. Alright, it's time to see this in action. On our source machine, we're viewing the customer tables data, and it's the standard database without any extra columns. We'll switch to the remote Windows machine where we're viewing the data warehouse version of the Chili Company database. This is the version that we created with our utility program and is now kept in sync with the source database on the Mac. The customer table adds an extra ESQL ID identity field, and scrolling to the end displays our added active and modified fields. On the bottom of the screen, we're tailing the BBJ log file so we can get real-time feedback whenever the triggers fire to keep the data files in sync. Switching back to the Mac, we'll modify the customer's first name from Gregory to just plain Greg. Clicking the Save button displays the SQL that will execute to make the change. After committing the change, we switch over to the Windows machine. Notice that our log file shows a new entry saying that Endecker wrote to the customer table. After refreshing our view of the data, we see that the change from Gregory to Greg has already taken effect. Scrolling to the end of the columns, we now see that we have new entries showing that Endecker modified the record along with a timestamp. So writes are being propagated correctly. What about removes? Our goal for the additional active column is to have it track the state of a record. When someone removes a record from the source, we don't really want to remove it from the target. Rather than lose that information, we just want to flag it as inactive. To test this, we'll delete the second customer from the data file. Switching over to the Windows machine shows another trigger log entry, this time saying that Endecker removed customer number 2. After refreshing our data view, we notice that custom 2 is still there. So far, so good. Scrolling over to the last columns reveals that the record has been marked inactive, and we have a record of who last modified it and when. Our triggers work perfectly. We now have our augmented data warehouse version of the Chili Company that's kept in sync with a remote source via BBJ's asynchronous triggers.